And we are broadcasting. And I see, so far we have an attendee in the room, and usually it takes a few minutes after the hour for attendees to pop in. And welcome to all of you who are just jumping in here. I love it when I see that list growing and growing. So I'll be saying welcome a million times over the next few minutes as people join. We won't officially get started until a few minutes after the hour.
That's okay.
Welcome, welcome everyone. Oh, terrific. Getting a good crowd. And let me just do two. I'll open my Q&A window. So it is just the top of the hour. I just want to give people who may still be joining a few minutes to come into the webinar, and we'll start in just a couple minutes. Thank you all for joining. I guess while we're waiting, Samia is clearly on a desert island somewhere, right?
I miss the beaches.
Yeah, me as well. Just one more minute. And then, I have a few sort of introductory slides about Women Who Code and the mission, and this is all recorded. Again, for those of you joining, we are recording, and we'll publish the link to the recording. But I also, given it's just a couple minutes after the hour, I'm going to go ahead and start. I have a few introductory slides, and then we'll get into the meat of the topic, which I'm really excited about today. We have Samia and Marko from ThoughtWorks who are going to talk about data mesh infrastructure by example, which is, the good stuff in real world implementations. And I am so happy to have them today and you all on the call with us. My name is Paula Paul. I'm a consultant and engineer and do this kind of work as well. But I am also a cloud track lead with Women Who Code. And the mission of Women Who Code is to inspire women to excel in their technology careers. We envision a world where we're at every kind of seat at the table with engineering, with marketing, with all sorts of leadership roles. From junior developers to architects and CEOs, CTOs, CIOs. So we want you all to be inspired by these topics. And we are an inclusive community, so anyone can be a part of the community as long as you're up for the mission and helping women excel in their careers in technology. We also have a code of conduct that is published. And I hope that you never have need to use this, but if you do have a need to contact us about violations of that code of conduct, please do. We want to hear from you, and we want to hear about ways that we can improve and better support this community. And a special thanks to VMware, who has been our CloudTrack sponsor, as well as the entire Women Who Code organization. We are active on social media. I will be posting the link to this webinar out on LinkedIn and a couple of the other social media platforms, but please feel free to share and please feel free to connect with us on social media. And with that, I am very excited and so very honored to have Samia and Marko with us today to talk about data mesh infrastructure by example and with ThoughtWorks. So I would like to turn it over from here and allow Samia and Marko to introduce themselves and regale us with their adventures with data mesh. I will stop share and allow one of you to share if you're able to. Let me know if you have any issues there. Okay, I can see it.
Okay. Awesome.
Oh, I'm sorry, Samia, I forgot to mention that if you have questions along the way, please post them in the Q&A and we'll keep a running list and address those questions towards the end of the discussion. So with that, thank you, Samia.
Hello, everyone. This is Marko. My name is Marko, and I'm joining from sunny San Francisco. So over the last 10 years, I've spent doing infrastructure, application development, data crunching, and so on. So at the moment, I'm quite into enabling companies or organizations to extract value from their data and helping those organizations use cloud in an effective way. Samia?
Hi, everyone. Thanks for joining us. So I'm Samia Rahman, one of the lead consultants at ThoughtWorks, and I'm joining you from Chicago. I've been in the industry for about 10 years, and I'm super passionate about extracting or unlocking value from data, similar to what Marko said. And today we're going to talk about an architecture that helps try to optimize the cycle of intelligence to unlock that value of data. And we're going to talk about the infrastructure that is needed in order to get that data mesh platform going. So without further ado, I will kind of start or kick it off with talking about that cycle of intelligence and how do you actually get value out of data. So when unlocking value from data in this cycle of intelligence, you're typically having to go and acquire some data, store and clean that data, derive some information and extract some insights, and then make some decisions and you make some actions. So an example here would be, I'm a data scientist or an analyst who's been tasked with, hey, figure out how to retain customers for the online home workout subscriptions we have. We're losing a lot of our subscriptions. So in order to do that, I would go ahead and identify some data sets that live in my organization and then go through this cycle of intelligence to make some or take some actions to correct or improve the retention of my customers. But in the cycle of intelligence, there's two key friction points that happen when I'm trying to implement the solution for that problem. As a data scientist or an analyst, I'm going to have to first acquire the data. So I'm in an enterprise, you're going to have large volumes of data. Right now, we have petabytes of information out there. And depending on the on your organization scale, it will be reflected in your volume of data as well. So I'm going to, as a data scientist, have to figure out what in this plethora of data, what data is actually useful to me. The second phase where I'm going to spend a lot of time in is, now that I've identified some potential data, I'm going to have to actually clean that data and try to derive some information. And it's going to depend on what types of data I have. So if you have variety of data, you might want to harmonize that data and then apply it on the analysis, the analytical code you're going to write. So how has the industry tried to solve for this problem? So we've all heard of big data platforms in the industry. In the last few decades, we said, hey, let's get good at acquiring the data and maybe cleansing the data and harmonizing it and put some structure to it, and then serve that data so that we can empower data scientists and analysts we've hired to make those intelligent systems. But there's still quite a few failure modes with those existing big data platforms that we've been implementing in the last couple of decades. One of the failure modes with big data platforms is we've been implementing it with a centralized and monolithical approach. So typically we make this assumption that because the source data in the enterprise, all that operational data in the enterprise is already aligned to your domain. That means that I can simply just move take all that data from those sources and put it in this data platform, do some processing logic, and then serve it up to the customers. But I might not be focusing on that processing logic. I'm thinking about just acquiring large volumes of data and just putting it in the lake and not really empowering my consumers. My consumers still have to go search the data in that data platform, and they still have to go and cleanse some of that data. With the centralized approach, there's another problem or another failure mode of making changes in this centralized system. Typically in these centralized big data platforms, a second failure mode is you have coupled pipeline decomposition. And what I mean by that is we've been typically saying that, hey, let's create an architecture component in this data platform that's able to ingest data. Its sole responsibility is onboarding data into the platform. And then let's have another component, which is processing that data and making some sense out of it, harmonizing it, enriching it, and then persist that, and then serve it up via some APIs or some access controls to consumers. But now let's say I'm the data scientist and I ask for, hey, this particular column in a data set, let's take an example of customer contact preference, and it has values of zeros and ones. When you put that, and to me, the data scientist, I need to understand what that 0 and 1 is, and there is no clear metadata, then I would have to contact the data platform team and ask them, hey, can you go find out from the source system what that means? And because my real-time application will actually depend on those data values, then could you make sure that you update your processing and then serve it up? So now the axis of change is going through vertically, which is orthogonal to those architecture components, which are the ingestion stages and then process stage and the serve stage. So this again increases that friction time in how you evolve the quality of your data in that big data platform. And then there's a third failure mode associated with existing big data platforms. Similar to the architecture, it usually reflects into your organization. So as the data scientist, I'm on the right-hand side. I'm frustrated. I don't have quality data. I'm far removed from the actual processing logic within that data platform. And the data platform teams, they don't really understand the domain, and they're far removed from the source teams who are maintaining that operational domain system. So with this these siloed team structures, as a data scientist, in order to actually figure out which data sets and what my cleansing logic or details need to be, I have to jump through 2 levels of organization to figure that out. And then finally, can I do some analysis? And this is where accounting for these failure modes, data mesh comes in with 2 key principles to try to solve for these problems. So the data platform can be built with a data mesh architecture, and the data mesh architecture asks for 2 key principles. The first one is treat domains as a first-class concern. Just because you have domains in your source or your operational systems, don't forget about maintaining those domains in your big data platform and just say, oh, it's gonna be a dumping ground, and then people can make sense out of it. So when you start putting that domain as a first-class concern and you create cross-functional teams around that data, then you're minimizing that friction time. The second thing that the data mesh architecture asks for is treat data as a product. So when you put a product facade on a data, then you're making it a digital asset. It's something that has to live up to certain properties and qualities that would minimize that friction for the data scientists and analysts to make sense out of that data. And there's a great article that's been published on Martin Fowler's website, written by Zhamak Degani, that details out the data mesh and how it solves for it and the compelling reasons to adopt this architecture if you're struggling to optimize your cycle of intelligence. And I won't, for the sake of demoing the infrastructure aspects of this with this webinar, I'm going to assume you guys are sort of convinced that data mesh architecture makes sense for this data platform to unlock business value. So now I'm going to dive in a bit deeper into what is the unit of architecture within the data mesh. So great, we figured out this is the architecture we want to use. How do I go about implementing it? So in order to actually create a data as a product, there's certain properties that the data product must offer so that our data scientists and analysts can be empowered to do their job. And there are 6 properties. The first one being it needs to be discoverable so that I can search the data and then I can use it. And then it needs to be addressable. So I need to be able to know where the data lives. There could be multiple data sets associated with a domain of a data product. So if it's customer profile information, there's like the address information, there could be the billing information, there's many aspects to it. So I need to know where those data sets exist within that boundary of the data product. Then in order for me to make sense out of that data, as a scientist, I'm expecting the data product to also give me the descriptions of those data sets. So a data set will have schemas, and those schemas will have details around what each field and what each field means. The other thing as a data scientist I'm hoping for this data product will do for me is it's trustworthy. So I can reliably use it, and the data is being delivered. If it says it's going to give me data monthly, then it is doing its job. So you want to make sure the SLAs and the SLOs of the data product are maintained, and you're holding that data product accountable for that trustworthiness. And then obviously a key feature with any architecture is security. And you need to make sure that this data product is secure and it's only accessible by authorized users. So in an enterprise, typically you will have a data governance department. And because you have PII compliance, or in healthcare, you might have HIPAA compliance rules, you will have to govern that data, and only certain tiered users based on certifications would be allowed to access that privileged data. So you have to account for that security aspect in your data product. And then the 6th property is these data products will need to interoperate. So depending on how you decide to apply those domain or apply the domain driven design approach on your data products might need to talk to each other in order to create some aggregates. So with those properties in mind, I'll quickly try to talk about what are some of the things that happen within the internals of a data product. So in this diagram, you'll see On the left-hand side, for ingesting data, we have some input data ports. You can have polyglot input data ports. I could be streaming in some information, some external information about some data, as well as taking in some blob type data that's living in some storage account. I'll apply some processing logic in the internal details of my data product, and then I'm going to write out the process data to output ports. Again, you can have polyglot output ports depending on your SLAs and SLOs. So I could have a streaming output port and a storage output port. Streaming might be for my real-time systems, and the storage or the blob type output port would be to empower exploration of the data by our data scientists. There's a few other ports that we identify a data product must have. So we call these the control ports. You're going to have a self-serve description control port. That's where you're publishing your metadata and what your data product is about and all the data sets that you're generating. And then you will also need, for the internal maintenance of this data product, you're going to need logs. You might want to generate some metrics around, hey, I processed a petabyte of data, but I was only successful in processing 50% of it because there's something wrong with some of the data points we received, or there's some new data points we've received. So these kind of things will help you continuously enhance that data product. So now that we've talked about the data product, let's look at an example. So I took an example use case with recent times in mind, and it's a very simple and naive use case. In this one, I'm making an assumption that on the left-hand side, my upstream data products, I'm dividing the domain by country here. So I have COVID data coming in from Italy, from US, from many other countries. And I need to create like a global COVID data report. And if I want to run this in like my healthcare organization, I might have other data products that I might also want to interoperate with along with this global data report. But for this, for the simplicity of the use case, here the upstream data products are source aligned to the country, and the sources are external sources. And then once I have harmonized and cleansed each of these data from each of the countries, then I'm going to make sure that the output data has a consistent field name convention, same with the US stuff, so that I can, when I try to make the global data analysis, I can enter or join all the data from the various formats of information and then generate the report. So some people might ask, hey, why not just go pull all the data and create one monolithic data product? You totally can do that, but there's a risk associated with it. Let's say you have a change in the source data that happened. Then now you're going to, let's say I had Italy decided to rename their columns or change the meaning of one of their columns. And in order to protect how those reports are changed and manage that change, if I had a monolithic data product, then that could impact all the other logic associated with generating that global report. So what I can instead do is, because I've kind of establish that boundary, I'm going to make sense of it and apply that logic and still maintain my output port data schema that I've offered in the past to the global data product, and maintain and isolate that change just to this data product, and therefore maintaining those changes in a faster way and updating the reports in a consistent way. So with this use case in mind, I want to talk about with this use case in mind, so we're going to now jump into how do you actually go about implementing one of these data products. So I'm going to talk about if I were the data product developer who has to create this COVID data product, then there's a user journey associated with it. just like the data scientist, I'm having to first search and identify the data products that exist in my ecosystem. And then I need to request access to that data. So we talked about data governance stewards in the past. Once I've requested access to that data governance stewards would approve that access. And then once that access has been approved, then I will get, I will be able to go ahead and build and deploy my data product. And the data analyst can go create those fancy dashboards for us based on that data. But the reason I present this user journey for the downstream data product for the global data is because that's going to lead into what our infrastructure actually looks like and how that access pattern will be established with the infrastructure. And this is where I'm going to hand off to Marko to kind of walk us through the actual implementation. Off to you, Marko.
Thanks, Samia. Let me share my screen here. Okay, do you see my screen? Cool.
Yes.
Okay, so now that Samia has introduced the concept of data product and what it actually means, I'll talk a little bit about what the actual implementation of a data product looks like. So for this implementation, we've chosen Google Cloud, and the technologies that you can see here are Google specific. This can easily be mapped to other cloud providers. So for now, we'll just talk about Google, but later we can refer to other cloud providers if needed. So here you can see the data, each of the data products has an input port, an output port, and some kind of logic, some kind of internals that are gonna do number crunching. Input storage in this data product one is, in our case, cloud storage bucket. Then we have BigQuery dataset as an output data port. And then we're using Cloud Data Flow as a platform for processing and enabling harmonization logic. One other thing that you might notice is that each of the data products has its own service account. Service account is used to give each of the data products an identity, and it's actually critical in achieving this data product construct. If you didn't have service accounts, it would be really hard to tell what belongs to which data product, and it would be hard to put a security boundary around each of those. You will also notice that each of these technologies is actually a shared platform. So for example, BigQuery, we could have, for example, BigQuery is an SQL output data port, and potentially we could have implemented it with some managed SQL database like Postgres, but we've chosen BigQuery because it's a shared platform. I'll talk a little bit more why specifically we've chosen BigQuery later when we can talk about the problems that you might encounter with data mesh. In the data product 2, you will see that the input data port actually maps to the output data port of the first data product. So there is no explicit input storage here, but the input is actually coming from the BigQuery of the first data product. And you can also see this temporary cloud storage. These are just some helper elements needed for Cloud Data Flow to work. This might be something else. So if you chose, for example, Kubernetes, you would probably have different things here. But the important thing is that each data product has a service account, and most of them are built on shared services. So I'll share my screen and I will show what this actually looks like in code. So bear with me for a second. Okay, do you see my terminal?
Yeah.
Cool. Okay, so here is the actual implementation of the two data products that I've been talking about, data product 1 and data product 2. If you notice, there is only 120 lines of code. It's actually even a little bit less if you don't if you don't count setting Google project here. So it's probably less than 120 lines of code here. So let's go quickly through the code and see what components we have here. So we've created two service accounts for each of the data product, which I mentioned already. Then we have an output port for data product 1. And you can see it's just a BigQuery data set, which we've configured, and we've used we've given owner access to data product 1, which has full access to this data set, and the service account associated with data product 2 is just the reader, so it can just read information from this BigQuery data set. Then we also have the input data port, which is the this cloud storage bucket that I mentioned, where data product 1 will receive its information or data that needs to be processed. So information here would be pushed by some other system, either some external system or some system that the organization has that wants this data processed. Then towards here we see data product 2 has an output data port, which is also a BigQuery data set, and we can see that there's only a service account for data product 2 that has access to it, so nothing else has access to this output port yet. These are data product 1 internal bucket that's used for processing, for data flow, and the meat of this is actually this security policies that I've been talking about. So you can see the majority of the work is actually creating, specifying correct permissions for each of the service accounts to be able to access components. So probably about 70% of the code is actually permissions here. I won't be running this Terraform code. Samia and I have provisioned this infrastructure ahead of time. Now that we have this infrastructure, now that we can actually run something within that infrastructure. We can run something within data product 1 and data product 2. So I'll hand over to Samia to demonstrate how the internals of data products actually work.
All right. Bear with us, guys. Need to do a bit of a screen swap here. Can you stop sharing, Marko?
Yep.
All right. All right. So based on the infrastructure that Marko just showed, what we are going to try and illustrate right now is that secure boundary concept of a data product. So we want to see that data product 1, because it is the owner of data set 1, it can go manage all the tables it wants to create on that data set, and so that the downstream data product 2 can consume from it. And so I'm going to run a real quick script to show that because Terraform has implemented or we've implemented the infrastructure with those secure boundaries in mind, it will succeed in writing that data set. So I'm going to quickly run that script, and you'll see it will go ahead and create a data flow job that simply takes some data and then writes it to the data set. And it takes about 4 minutes for the data flow job to actually complete. So I'm not going to show you guys the entire thing like succeeding. We've already run it previously. So I'll show that right now on data flow. So this is a past data flow job that succeeded in writing things. And there was a table associated with it. So in DP1 data set 1, I had a test table, and we should be able to run things unless things got wiped out. Looks like something happened.
All right.
Uh-oh. Okay, let's see. So you can see that the data flow job actually gets created and it's going to run and takes about a few minutes for it to actually get created. Still taking some time, but essentially you can see that the data product or the data flow is getting created, and I'll quickly jump into showing that that secure boundary concept is still maintained. So the second demo I'm going to show you while that's running in the background. 1 second. So I'll trigger off another job in which I'm going to show that I'm going to use that same data product one's service account, but I'm going to try and write to data product two's data set. And in this one, because we didn't give it any permissions to be able to do that, it will quickly come back and tell me that, hey, I don't have, I'm not allowed to write data to data set 2. And you'll see I get an exception saying, hey, 403 permission denied, you don't have access to data product 2's data set. And that kind of illustrates that secure boundary we established. And I apologize that some things went wrong in this live demo. Let's see if I can see that. It seems like it's still running. I guess things go wrong at the last moment. But this is a previously, a job that ran successfully that we ran in the past, and it took about 5 minutes for it to complete, and it was able to write things to that data set 1 successfully. So that kind of illustrates that simple principle of around secure boundaries and applying least privilege principle. And I'll hand back to Marko now to kind of talk about certain other factors that you need to keep in mind when implementing the infrastructure.
Give me a second, please. Okay, so now that we've seen what data products look like and the actual implementation of 2 of them, let's talk a little bit about scaling those data products. Because data mesh, the idea is that you can have lots of data products which are interconnected in different ways. So 2 data products might sound very simple, but data mesh implementations would have dozens, even hundreds of data products in the data mesh. So as you scale these data products, you'll run into different challenges that you probably haven't encountered before, like we did on different projects. So some of the things that you'll need to think about is about one big thing is infrastructure and shared infrastructure. One naive way of thinking is saying, okay, each of the data products will have their own infrastructure. So if you go with that approach, you'll quickly run into problems with cloud provider limits, with excessive costs, with permissions, and so on. So if you're, for example, using SQL ports, you probably want to look at what kind of databases you can use, but you also want to share those databases. You don't want to have one database per data product, because that quickly becomes prohibitive from cost perspective and as well as management perspective. Blob data ports are another place where you might have challenges. So different blob technologies like in Azure and Google Cloud have different APIs that are used to access those. And they have different constraints. So for example, in Azure, you might have container storage. In Google, you have Google Cloud Storage, and they are very different in terms of performance, in terms of constraints that they put on you. I think in Azure, you can have something like 200, 300. I think Samia knows better that specific number. But there is a limit of storage buckets that you can create, while Google Cloud, you can create as many as you want. So for example, depending on which cloud provider you choose to go with, you may or may not have an issue with that. Streaming ports are still relatively new, and different cloud providers implement different technologies. So Kafka is a very common streaming technology, but then once you start using those, you run into issues around security and how do you segregate single Kafka instance so that multiple data products can use it, and how do you put a security boundary around it. So depending on what technologies you're using, so for example, we used BigQuery in this example, and BigQuery maps really well to Google security model and service accounts. But if we, for example, try to use PostgreSQL, then we would have issues with user accounts that Postgres actually manages. So we would have to have a system that maps service account with the user account in Postgres database, which adds an overhead that we didn't feel taking on. But depending on what cloud provider you go, you may not have BigQuery, you might actually have to use SQL database, and you might need to solve that problem as well. I've talked about cloud provider resource limits. Each cloud provider gets puts their own resource limits for whatever reasons. The ones that you'll run into are usually around network and firewall rules. Sometimes some providers put it, for example, Azure puts it around their cloud, around their storage containers, number of storage containers, number of service accounts. The other cloud providers might have might not have those constraints, or might have more generous constraints. So you'll need to think about those ones. You definitely think about cloud resource limits once you go into the data mesh, and you should seriously consider which cloud provider you use, because they are actually quite different, all three of them. When I say three, it's Google Cloud, Azure, and AWS. You'll also need to think about volume of data that you're processing, frequency of processing, and SLAs and SLOs for the output ports. So when I talk about volume of data, you might want to consider, if you, for example, have one data product in US region and the other one in Europe region, you might, and if you're shuffling a lot of data between those two data products, you might actually have excessive ingress/egress cost. So you might want to consolidate it into one region just for the cost reasons. Frequency of data processing is another one where you can actually optimize quite a lot. So you might, for example, run a Kubernetes cluster for data products, but if all of your data products process data once a month, then you will be paying for Kubernetes cluster for the whole month, but then using it maybe a couple of days. So there are different technologies that you might use. So in this example, we used Cloud Data Flow, which is pay-per-use. So we submit a job and we pay literally for the amount of time that that job runs, and that's it. So that's a great piece of technology if you have a data product that needs to run infrequently or needs to do some computation, like maybe once a week or once a month. So you just pay for what you use. If you had a data product that needs to be streaming data, then you probably need something that's a little bit more permanent, maybe Kubernetes cluster or something like that, or some other technology. SLAs and SLOs are the other things that you will want to establish, and you will need to think about what kind of tools does provider already give you to monitor SLAs and SLOs. So how long does if a data product one makes a request for data, some data in another data product, how long does it take? What's the latency, and how often do you see errors? You will want to be monitoring those things. So you'll want to think about technologies that cloud providers already give you to monitor that, or if they don't give you, you will need to implement something like that. So now that we've talked about technologies and problems with potential ones, you'll need to decide eventually which cloud provider and what tech stack you'll use. But what else do you need in order to scale to hundreds of data products? So we've decided on the tech stack, but how do we provision all these data products? So in this toy example, we've used Terraform, and it's really easy. But when you get to hundreds of data products, they will have different life cycle. They will come and go at different points in time. They will have different problems. People will need to somehow request them, and the organization will need eventually to know where those data products live and who owns them. So you'll need to create some self-serve platform to help you provision all that infrastructure and manage that. You will also need to think about the support model for these data products that you provision. So one way would be, so for example, if you have a data product and there's a security issue there, you might need to roll out a fix for it. So one way to do that is just to roll out everywhere without asking any of the data products, which you can do, but you're putting your business at risk by potentially breaking different data products that are already running. And so on. The other approach you might use is an incremental rollout, where you actually do the fix, but then give a chance to the data product to actually say, okay, I'm ready now to deploy to new infrastructure, and somebody's going to click a button and that happens. So this is what this infrastructure, or self-serve infrastructure, should provide you. You'll also need to think about, once you have hundreds of data products, your data engineers or data scientists will want to be able to find those data products. So you'll need some platform to do the discovery. And on top of that, you'll also want to think about access controls, because data products in large enterprises, they will have potentially sometimes PII, PHI data, or whatever. For some reason, not everyone will always have access to all of the data. And somebody might need to request, somebody might need to approve it. Samia already mentioned that in her example in the flow. So you will need a platform to allow the access control for it. You will also want to think about how do you implement this access control? So for example, in some cloud providers, it's easier than in the others. For example, Google is relatively good because they map their security controls quite well to the underlying infrastructure, but some other cloud providers are not there yet, and you might need to use some other third-party products in order to achieve that. So you might need to look at something like Open Policy Agent and putting potentially some kind of proxies in front of your different technologies, putting some kind of proxies and then hooking them up into your governance platform in order to help manage access to these data products. Discoverability is another tool. Like in Google, you have Google Data Catalog, which is relatively easy to hook into data products. The other cloud providers don't really have the equivalent of data catalog, but there are off-the-shelf products that you can use and install. So these are some of the things that you might need to consider when you deploy this self-serve platform. So given all these things that I mentioned, so some of the key points from here or from this talk is that you should be treating your data as a product, with the domain as a first-class citizen. Decentralized data products does not imply decentralized infrastructure. So think about more of a shared infrastructure and how do you map data products to a shared infrastructure. Every data product must have a security boundary, which comes with an identity as well. Be mindful when you go to cloud providers, be mindful of scaling constraints that you might encounter with those cloud providers, and make sure that you have some self-serve platform to help you manage this data mesh. So now, having said that, we're open for questions. So actually, before we go to questions, there is some references here. So the code base that we've used, you can find on GitHub. If you want to know a little bit more about the data mesh and the theory behind it and theoretical constructs, there are two great articles by Zhamak, one on the Martin Fowler's blog and one on the InfoQ blog. So feel free to check that out. And you can always reach out to us via email if you have anything that we haven't covered or are interested to know more. So having said that,
maybe what I can do is just jump in really quick here and say, this is amazing. I really enjoyed this presentation. We have about 10 minutes for questions, give or take. And also, I think this is a great complement to breaking code into products and having them secured and having standard interfaces. And then we have infrastructure as code. And it really feels like you can apply a lot of those same principles now to data as data products. So it's really exciting for me. I'd like to have these questions put out, but I don't know, Samia, you've seen in the Q&A, are there things that you want to address here in the real time? And then we can take some, if we don't have time, we can do async. So why don't you kick us off with questions?
Yeah, sure. So I think the first question that we saw was very interesting. What are some of the bigger technological hurdles to adopting data mesh at a company that already has an existing data solution? I think both Marko and I have seen interesting perspectives in that. So it depends on your company's maturity level and where that existing solution is. If it's on-prem, then there is the learning curve of actually going to cloud. If they are planning to go to cloud, data mesh doesn't imply that you have to implement it in cloud. You can actually implement it on-prem as well, as long as you're sticking to those principles of establishing that secure boundary. And then the other organizational challenges is actually talking about data as a product. Like we presented earlier, because your organization is probably already siloed, you're going to have to make that organizational transformation around, hey, we can no longer sustain operating the way we have been, and we now need to think about it from a different perspective. So you need to bring your source system folks and incentivize them, and you have to bring the data platform, the existing data platform owners closer to thinking about that domain, and also talking to their customers, which is their scientists and analysts. Marko, did you have anything more to add to that?
Yeah, so I think some of other technical hurdles is the fact that some of these technologies needed for data mesh is relatively new construct, and it's just been over a year that we've been talking about it. So there is still a lot of, if you go to cloud providers, some of them are more friendly for data mesh than the other ones, but there is still if you're going to on-prem, there is a lot of tooling that you will need to manage yourself in order to support something like that. And the lack of the lack of physical or implementations that people cannot reference, implementations that people can use to implement in their companies is still not there. It's still coming out. So this is one example where we implemented a simple data mesh in Google Cloud, but it's very hard to come across examples that you could just take to the company and say, this is how we implement it. So I expect within the next 12 months, we'll see more of this tooling coming along. So things like Open Policy Agent is getting more mature. So basically putting unified permissions across different technologies, like for example, SQL or Kubernetes will help with that. But yeah, so just to answer your question, the technological hurdles, in my opinion, is the fact that there is not enough reference implementations, and technologies are now just catching up with data mesh construct.
Yeah. And yeah, depending on your cloud provider, I think that's what Marko was talking about. You're going to have resource constraints. Like the biggest pain points are usually resource constraints, and how do you do that secure boundary around your infrastructure and account for the volume of data and all those factors. So you're constantly taking those factors into account and making tech stack decisions for your infrastructure. We can move on to another question, I guess. There was, so we show the Terraform infrastructure as code. What about CI/CD for Java code and data flow, including unit and integration tests? So this webinar was focused mostly around the infrastructure. Those are the application layer concerns, and those are things we're hoping to create more demos around. It's the same principles you apply for any processing applications. If you're familiar with Spark, then you're creating Spark session tests with example files, and there's a whole test pyramid associated with how do you solve for application, or how do you give yourself that test harness to for future refactorings. So those could be future topics we would love to present in the future if there's an opportunity. So I guess we can move on to another question. So this one is interesting, I guess. Would it be wise to have harmonizable data products across cloud providers? Do you want to take that, Marko?
Yeah, so I don't think there's anything that says that the data products cannot be across cloud providers. It's actually implied that data products could be across different cloud providers. This specific implementation used one cloud provider. And if you decide to venture on the journey where you want to cross cloud boundary, you probably need to think about how are you going to create this self-serve platform, and how are you going to create an abstraction layer on top of those two clouds, so that once you create the data product, it shouldn't really matter which cloud you're in, because you're working with the data product. So you need to think about the next level of abstraction that you will create on top of those cloud providers, and then the technologies that you might need in order to hook those up. Because permissions in, for example, Google Cloud and Azure will be very different. So in order for you to be able to connect those, you'll need to almost like step a layer up and use different technologies, like maybe Open Policy Agent for permissions management. And you might need to create potentially some kind of proxies in front of different, for example, blob storage. Blob storage in Google has different API than it has in AWS or Azure. So you might need to create a proxy in front of that to abstract that API and make it more uniform. So yeah, there is nothing that says data products cannot be across cloud providers, but it will be more challenging if you decide to go on that venture.
The other question, I guess this is about what do teams look like in data mesh approach? And there's another question about teams which, okay, yeah, so I guess we can try and answer what do teams look like in data mesh approach? So it's going to depend, again, on the maturity of your organization, but one of the asks is you need like a cross-functional team, just like we do for our operational systems. We'll have an application system based on the domain. So you might have the claims, if the domain was like the payments or the billing of your company, then you might have a team that's responsible for maintaining that billing system. So you're kind of organizing by domain so that there's that ownership around maintaining that data product and serving the customers associated with that data product. So team structures will usually compose of your data engineers. You're going to have maybe someone from infrastructure embedded in there to help operationalize it initially in the early stages. But if you build that self-serve infra, you don't really need the infra expertise. You're literally using the same kind of tooling around CI/CD, and you're also expecting infra as a service. So you basically wire those things up in your configuration and you deploy it. So the platform will help address some of that cross-functional things you need. critical things with a data product ownership is you need to identify a data product owner. And this is where I think a lot of organizations struggle, because everyone's so far removed and no one knows who's the true domain owner. You have the governance sitting far away from the data platform engineers, and then they're far removed from the source domain system. So I think it needs to come from that product ownership, and it could be that a product owner is managing multiple data products because they're interrelated. So that's also okay. So it's up to the team to decide what are those domain boundaries within those data products. So there's no hard and fast rule that one data product is equivalent of one team, which is composed of XYZ engineers. It's going to depend on the nature of the problem and how you decide to solve for it.
I could take one. I saw the question most recent was about data lakes versus data mesh. And my concept, and you tell me if I'm off here, that it's not an either or. I think of a data lake like an aggregator, like if I'm doing log aggregation, whereas maybe the data products are like specific dashboards built off of information that comes out of that aggregator. And you still need both. But is that the way you look at it? Or have you seen people add data product thinking to existing data lakes?
So to me, data lake and a data mesh, it's still housing the data. So underneath the data mesh, I think those two words can get easily conflated. Data mesh is bringing that product thinking on your data lake. So if you have an existing data lake, you have all those data pipelines, you might want to reassess and look at your data and be like, okay, these data pipelines can be encapsulated into this domain. And so I'm going to make it easily available and accessible for sorry, Marko, I think there's some background noise. Sorry. So you can create data products on top of your data lake, as long as your data lake is helping you have those platform needs that you need in order to create that. So I think if you have existing data, you can totally spin up a data product and encapsulate and identify those domains.
And we have one more minute. So is there a quick one? We're at the top of the hour. If not, I can say, again, this was tremendous. I really, really enjoyed it, and just the demos and the depth of it. And thank you for venturing into actual demos, which always break when you're live. So thank you. And we will publish this recording, and I have captured the questions. If we didn't get to anything, I'll send those over to you, and we can publish those with the webinar.
Yeah, I saw some interesting questions. Feel free to reach out to us. We can definitely respond to them. Thanks.
All right. Thank you so much, everyone. And thank you all for joining.
Thank you.
Stay safe.